Hello everyone. Can you hear me? If you can, please drop a comment. So let's start. First, I'm going to introduce myself. I'm Wafa. I am a robotic teacher and I am an embedded system engineer. I like doing stuff with the Edge II and embedded II. Today's session is about deploying object detection model on ESP-CAM. In our first session, we deploy it using Edge Impulse and Arduino IDE. Today, we will learn how to train our own model using YOLO version 5 and deploy it using ESP-IDF. I'm very excited to this session. So if you have any comments or chats or introduce yourself in comments, I like to have meaningful and inspiring conversation with you all. So I will share my screen. Okay, I think you can see, I will share my entire screen so everything will be clear to you. So first thing, we're going to train our model. In machine learning in general, we have to collect our data, label it, and then train it. So since we are using ESP32 CAM, the best way is to take the data, the picture of your data. For example, here we are going to do an egg detection. It's better to use ESP32 CAM to take your data for better results. Here, after I take my data, I'm using this site. It's called RoboFlow for labeling my data. I will show you here. First, I upload my data. It's here. I will show you my data. It's contain 38 picture of eggs. I take it with my ESP32 CAM and I upload it to this site for labeling. After I label it, here it's my data. After the labeling, it will be split to test and validation and train data. For example, here this is a validation data. I can change it or do it after I do the labeling, of course. For example, here, after I do all the data, here I have 28 picture. After I do it all, I return to the site and it will give me download options. I can download it as a zip file to my computer or or I can download as a code. Here, it's better to download it as a code, because later I will go to use Google Colab for the training. So that's for the data. I will show you the training code that I did using YOLO5. I will explain. I use Google Colab because I don't have the best power processing PC. So Colab is a good option. It gives you free GPU, and it's good for machine learning and machine learning stuff. Here, after I clone the YOLO5, and also here the code I used for I copied from the link they gave me in RoboFlow. I passed it here. So this is after cloning the YOLO and passed the data sets I had. All what I had to do is to set the parameter for the training. Here the image size and the batch size. Here I did 16 batch with 100 epoch, and start my training. Here I'm gonna. It's might take time, so I'm jump to the results. So I will show you the results. Yeah, here after the requirement, I install the requirement and everything. As I said, I'm using YOLO version 5 here. Here, like you will see here, 2 from 99. Here, as I said, I'm using 100. Wait a minute. 100 epoch. So it's going to be train 100 time. Here 2 from 99, from 0 to 20 to 99. So until it completes all the epoch, it will give me my model. Here. Yeah. So I here until 99, from 99 epoch, it gave me my model. The thing in Google Colab, you have to be very careful with the file you are using. If there is a file you have to download or something, you have to download it and put it in your computer because it won't be saved. Here, you won't see anything. But here, for my case, it's there. So I will find my model here in run trains wait best PT. So I'm going to YOLO version 5 and I will go to runs and then train and then examples, and wait, I will find my model here. It's called best PT. I should download it. Be careful, because if you don't download it now, it won't be there the next time you come. Just to be sure that I'm seeing. Okay. So sorry, not this one. This one. So this is the model, but it's in YOLO or PyTorch. So, we are going to deploy it on microcontroller. So we have to convert it to TensorFlow, then convert it to TensorFlow Lite. YOLO give us this. Give us the choice to do that directly from its repo. I will show you how to do that. It's like actually one line. I take it from another thing. I inspire a lot from this repo from Daniel to do the projects. I inspired from it a lot. So with this one, I will share it in the comments. I will share the repo I did also in maybe in the community later. Yeah. I will continue with one. Yeah, I forgot from with one line. Yeah, after the training, it's you will have your model in TF Lite only with this line. After you clone the YOLO version 5 to your computer and do this line of code, you will be your code will be converted to TF Lite and ready to be deployed. For my case, I was cloning the YOLO, and it takes forever, and it didn't clone yet. But I already have my my TF Lite ready from the previous time. So this is my model. It's in TF Lite. The model that I did in PT, I converted to TF Lite. Now, after we had our model, the only thing we got is to deploy it on ESP32. What we are going to need, we are going to need an ESP32 CAM and FTDI programmer and wires, and we do it as we wire it as the picture shows, and we'll go to deploy it. So, anybody have any question about the training parts? Anybody have question about the training part or anything you didn't understand about how we get our model? I would like to discuss this part further. Actually, it's not like big deal. It's only taking picture of your data and then label it, and then try to train it with YOLO. It's a very easy process, and you will get your model ready. I will stop sharing for a moment. Yeah, I will share again. Yeah, so for the next part, we are going to deploy the model on the ESP-CAM. What we are going to need, we are going to clone our ESP-IDF. Here, I have my ESP-IDF environment ready. And first thing, we are going to create a new project and export it. We'll need the terminal. Just a second. Yes. Yeah, let's do a new terminal. Yeah. So first thing we had to do is to go to our ESP-IDF file and then get the environment ready by exporting it. So this is the line is to get the environment ready. That we are going to create an ESP-IDF project. Then create a new project using like this line. Yeah, create a project. Let's create like new project. We call it ESP32 CAM, for example. And then we will like when we go here, we see that we did ESP32 CAM. It will create a CMake file, and it will create ESP-CAM C file. This is the main file. So, and then let's continue to our. Then let's configure our environment. We are using the camera here, so there's yeah, I forgot to ESP no yeah, I made a mistake. Just go here and ESP32 CAM. Let's go to this file and then run menu config. This is the configuration. We will get the configuration of the project here. Yeah, so this is the menu. We go to component configuration, and then we go to camera configuration. So here we are. I'm using ESP32 CAM. So this is the that should be checked. If it didn't check it because the not this one. Sorry, this one. If it's not checked, please make sure it's checked. Also, we have to check the PS-RAM because the camera needs ESP-CAM. Make sure it supports it and check it. Configuration, you don't need that. So that's all, and then quit. Don't forget to save the information. Then let's create the code for our projects. Forgot one thing also to say. So we have our model in TF Lite. To work with it in C or C++, we have to convert it to C array. So using this, I have like the model, as I said here. I will copy it and put it in the ESP-IDF ESP32 CAM. Then put it here. Yeah. Then let's convert it to C array using this code. Yes, it's a function called xxd that's converted TF Lite to a C array. After I enter, you will see that we no, it did not yet. Wait, maybe it didn't work. Yeah, there's no yeah, I want to put it there. I will put it here. Yes, here. Yes, the model data. See, as you can see, it's been here, but I don't need it here. I need it in the main file. Yeah. Yeah, let's see now. The main. Wait. Yeah, like we can see, this is the file we need. I will put it here. It's C file. As you can see, when we enter it, we will see it as an array. So this is the model in a C array. Then let's create this C. Since we are using a model, we are going to deploy it using a C++ file, not a C file. I will show you the code we are going to use. Not this. Take pictures, make, hello world. So I will. This is the code I prepared. Yes, the code I prepare. I will just. Yeah, so this is the code I prepare. I will show you. I will explain it. So here I include. So here we are going to use TensorFlow Micro Lite. It's specialized for microcontrollers, and we are going to use ESP32 CAM. After I include the libraries I need to configure the ESP32 CAM pin. It's so if I'm going to use ESP32 CAM, I have to configure the pin of the entire microcontroller, so it will be known to the when I flash it. So after I configure all the pins, I will set the image wide and high and the channel and everything. Then I'm going to configure the tensor arena. Here our model is not a big model. You have to not do a big model because it won't handle the RAM or the memory on the ESP-CAM. And you have to say exactly how much RAM you're going to need. Memory you're going to need. Here I'm going to use the it's like, I think the maximum is like 8 megabytes. Here I'm using 5. And then the model, and then the reference of the model. It's not here. And the model that we did it in stereo just in a minute. Then this is the camera configuration. Yeah, this is the camera configuration, the pin, and like we did to the microcontroller. And then function to process the image before feeding it to the model. We're going to take a picture and then give it to the model for processing to see if there is an egg or there is no egg. And then this is the main function, and she loads the camera and load the TensorFlow model, and also the input tensor. As I said, no, there's it's not the same like tensor or tensor arena. The tensor is like the information feed into the we take from the model. For example, here the tensor is the egg, and then run the interface, then read the model output. Here it's going to see if egg print if the prediction is good, then egg detected, else there is no egg, and flash it to our model. Let's see here. After I convert it and did the menu config, all I have to do here is to flash it. Wait, it's not. I will change the ports. Maybe it will be recognized. It's not. Yeah, I forgot something to tell you. Here, make sure that the IO0 is connected to the ground for the flashing. Here, it's not. It's not connected, so that's why maybe it's not recognizing it. This is the flashing mode. And let's return. Let's change the port, maybe. Flash. Yeah. Yeah, here I have a little problem in my camera. The last week it was working fine. Then when I was testing it this week, I found that it broke. So this may be going to be an issue. But I will show you. I will bring another model next time and share the results in the community. But for now, I will show you that it's been uploaded, and the only problem here is the camera because it's not detecting anything. But the microcontroller is working fine. So I will show you just the deployment smart part, not the results parts. I think I stepped on it. I'm not really sure what's happened to it because last week when I did the last session, it was working fine. But now it's not working. Yeah, it's a really sensitive microcontroller, especially the camera module. But it's I tried it and it's worked really well, and that's all what you need to get your model deployed. Yeah, it's writing to the microcontroller, and after it's completes the flashing, you had to disconnect the IO0 from the ground and press the restart button. So as you can see here, it's It's working fine, and it's ready. And it's waiting for the camera, but the camera is not detecting anything because, as I said, it was broken. So that's it. Do you have any question or any other clarification you like to know? I would like to explain further. I will stop sharing the screen. Actually, it's like very fun project to do. It's like a machine learning project with the embedded system devices. If you go through it, you will have really fun doing it, from taking the picture to train your model, to deploy it on and see the final result. It's really fun to do. If you don't have any question or anything, I will. If you have any question, maybe later or something, I will drop the community link. You can ask there anytime. Anytime. I will be in the server as my name is Wafa Atiash. And also you can. There is an HII channel in the server. You can find me there, or the general channel, or any place. To know if you have any question. Great. And as I said, I will share the GitHub repo for the of the previous session. As I said, we used Edge Impulse for the training and for the deployment. Actually, it's not a very big different process, but I personally think that training your own model using YOLO or TensorFlow, it's a way better and more professional way to deploy it on ESP-CAM, because it will be more customized. Because why not? We can do it. Also, also I prefer using YOLO for the object detection or dealing with images in general. I think it's more compatible for the images, and TensorFlow is more for classification. Yeah, like image classification or temperature or anything. That's my personal opinion. Of course, you can use TensorFlow for object detection, of course. But Edge Impulse is used, I think, FOMO for the training, and then converted to TF Lite. Yeah, so that's it. If you don't have any question, I will end the session here, and thank you so much, Umesh, for attending. I will see you the next session. Yeah, bye. Thank you all for attending.